So I'm going to talk about an EtherCAT panel to control a variable stiffness tendon drive. The idea is we have an output pulley connected to a link, in this case it's going to be a rod, and we have a drive pulley on the left which pulls the output pulley in one direction via tendon, and we have another one on the right which pulls the output pulley in the opposite direction via a tendon. We actually built this construction from, first of all, on the basis of an aluminium frame and added components using 3D printing. As you can see here on the left hand side we have a worm drive motor with an attached encoder, and the same kind of arrangement on the right hand side, worm drive and encoder, and these drive the output pulley, which also has an encoder, via these variable stiffness tendons, and by co-contraction you can actually change the effective spring constant of these things, and these basically will drive the link left and right. In order to actually control this, we built an EtherCAT panel which is based on DIN rail construction. At the top we have power supplies, just below it the power distribution, circuit breakers and so on. Then we have the Beckhoff PLC, which is basically an embedded PC which runs on Beckhoff slices which nicely fit into this bus that Beckhoff had developed. Finally we have a connection box at the bottom, which then we use to connect to the motors and the encoders. Here we see the system running open loop between different angles, just to demonstrate that we can actually run this. This is using slices, Beckhoff slices for encoders and motors. And here is a typical trajectory of open loop operation driving between target angles. Thanks very much for Innovate UK for support, as well as the University of Plymouth and also for Fieldwork Robotics.